So dear students, welcome to my YouTube channel PCM Academy, and today basically I will discuss about Constraint Equation. So we are in actually a lecture series on Newton's law, okay, for JEE Main, NEET and JEE Advanced, and some basic concepts involving in some mass pulley system, some motion on inclined plane, as well as some basic numericals, concept developing numericals we have done already. But today in this class we are going to introduce a new concept for basically for problem solving purpose, and that is constraint equation. Okay, I have written over here constraint equation. Now at first we have to understand what is constraint equation and why we need constraint equation and what is actually mean by constraints. In a single word, if you ask me what is actually mean by constraints, then I will reply with the word that constraints means actually restriction. This is the similar meaning of constraint is restriction. And some little bit of story about constraints I have told when I was telling about a normal reaction. Okay, normal reaction is one type of constraint force actually. Tensional force is also one type of constraint force. They are make some restriction on an object, and of course the restriction is on the motion. Okay, on the motion of object. So constant is basically a restriction which is imposed on an object for his motion. Actually, we will see in various cases, in various situations, that the motions of a body or an object is restricted somehow, and then the word or the concept constraints comes. Okay, so let me take some example to understand what is actually constraints, what is actually mean by constraints. Okay, and then I will move to constraint equation. Why we need constraint equation? First we need to understand what is actually mean by constraints. Okay, so let me give an example, a very good example, that suppose you are in a lift. Okay, suppose you are in a lift and the lift is moving with an acceleration a and you are inside the lift. Okay, so your motion is restricted along the vertical direction. You cannot move up and down along vertical. You have to move vertically with lift. So this is the constraints that are imposed on you or your motion, that you have to move with the lift either vertically or downwards. But you don't have any restriction along horizontal direction. You can move in this direction as well as you can move in this direction. So along horizontal direction you don't have any restriction, but along vertical direction you have a restriction, and the restriction is due to here normal reaction. You cannot go through the lift, or you cannot penetrate the floor of the lift due to its solid nature, and that's why force is appear, that is normal reaction is appear, which is actually opposite to the motion of the object. Here the tendency of motion of the object is downward direction, so normal direction is upward direction. So in this sense, this normal reaction is constraint force, because basically the normal reaction is actually acting opposite to the motion of the tendency of the object of mass m, which is downwards, and the downward motion is restricted by the normal reaction n. But along horizontal direction you don't have any constraints, so your motion is not constant along horizontal direction, but the motion is constant along downward direction. You cannot move downwards. But if you try, you can upward in upward direction. If you jump, you can and move upward direction because there is no constant. But strictly I can say that your motion is strictly constant along the vertically downward direction. Okay, so this is one type of constraint, and here the constant force is normal direction, and always there is constant force when a constant motion is involved. But there is a very good features about this constant force, that the work done always by the constant force is zero. But these kinds of things we are not analyzed here. These are the things of actually higher classical mechanics, where degree of freedom, generalized coordinate, everything is involving these constraints. But we are not discussing over here that kind of things. Here our purpose is very simple. We want to formulate some constant equation for some particular system, so that we can solve problems easily. We can get extra equation, okay, to solve problems. Sometimes we will see that the number of equation which we will get from Newton's law, okay, the by using the Newton's laws of motion, the equation which we will get will not be sufficient to solve problems, okay. And in that case, the one extra equation we will get from this constraint equation. I will discuss all the thing, but now let me give you another example to understand the constant force, like about the constant equation or the constant motion, you can say. Suppose we have a like inclined plane like this, inclined plane, and here is a mass of m, and here also the mass m is bound to move along this inclined plane. So here also its motion is restricted and it have to follow this downward path, this inclined plane, okay. So here also the motion is restricted and the object have to move along this downward direction, so its motion is also restricted. Even my motion is also restricted now, because I cannot go through the floor, because there is also restriction due to the solidity of the floor, okay. So you will see everywhere, you will see that the motions are somehow restricted. So if we once find out the restricted motion, the particular restriction, then we can easily understand what is actually constant equation. That when the restriction is written in the form of equation, in mathematical equation, then we will tell it constant equation. This is very simple. There is a restriction in almost each and every motion, there is a restriction, and we need to formulate this restriction mathematically by using equation, and that will be nothing but constant equation, okay. So let me take another example to understand the thing more clearly. When we need actually this constant equation, we will understand it better when we use some example, okay. So let me take a very simple case, the mass pulley system that I have discussed earlier previous class, and that's what the first case. This is the most simplest mass pulley problem, and you can say the most simplest constant equation, okay. Suppose this is a mass m1 and this is a mass m2, okay. Now we are asked to find out the acceleration of these two objects. So in the previous class I have assumed that the acceleration of mass m1 is in upward direction and the acceleration of mass m2 is in downward direction, but we assume that these two accelerations are same. But there is what is the mathematical reason behind this? Why we have taken these two accelerations are equal? We can get the answer of these things with the constraint equation, okay, because this is our prediction. The system is very simple, so we can predict easily that if this mass is moved upward and with an acceleration a, then this mass will move downwards with an acceleration a. And what is the reason behind it? Do you know? The reason behind it that the length of the string or the length of the rope is fixed, okay. And this is actually the constant here, that the masses m1 and m2 cannot move in such a way that the length of the string is extensible or it will increase. So here the restriction is the mass m1 and m2 have to move by making sure that the length of the string is fixed. So this is the constraint here, and if we use this constraint in terms of equation, we can easily see that these two accelerations are equal and opposite. So let me do it, okay. So to get the acceleration, we have to first find out the displacement relation between m1 and m2. Then we can find the velocity relation between m1 and m2, and then at last we can find the acceleration relation between m1 and m2. So to understand this thing, let me first take the acceleration of m1 is a1 and the acceleration of m2 is a2, and we need to find out the relation between a1 and a2, okay. So what we will do, let me locate the mass m1 with some reference line. Okay, so let me take this is the reference line, and from this reference line the position of the mass m1 we can take it as x1. So let me take the position of the mass m1 is x1 and the position of the mass m2 is x2. m2 is x2. m2 is x2. Okay, so if the length of the string is always fixed, that is the constraint, and here of course the constant force is tension. If the length is not fixed, length is inextensible, then the tension will not remain same. I have discussed earlier. So here the constraint force is tension. There in the case of lift, the constant force was normal reaction. Also when the block is moving downwards along a plane, here also the constant force is normal reaction, but here the constant force is tensional force. And the constraints is basically the length of the string is fixed. And when we write it in the form of equation that the length of the string is fixed, so what is the length? That is x1 plus x2, and you can put the extra length here. Okay, this is if we take the pulley as a radius r. Okay, then this length is nothing but pi r. So the total length of the string will be x1. Okay, plus this length, that is pi r, plus this length, that is x2, and this will be constant. This will be constant, and this is the constraint equation that I have written over here. And this pi r is also constant, so it can move in this side. So x1 plus x2 is equal to constant. So this is the displacement relation between these two objects. Now if we want to know the velocity relation between these two, what we have to do? We have to just differentiate it with respect to time. So it will be dx1 upon dt plus dx2 upon dt will be 0. Why 0? Because the differentiation of constant is 0. So it will be v1 dx1 by dt plus v2, that is equal to 0. That means v1 is equal to minus v2. So you can see the thing easily from this mathematical equation that v1 is equal to minus v2. So if the velocity of the mass m1 is in this direction, then the velocity of mass m2 will be in this direction. And similarly, if we make differentiation once again, then we will get the relation between the acceleration. So this dv1 by dt is a1 and this dv2 by dt is a2. So a1 is nothing but equal to minus a2. So we can write this as a and this as also a. What I have written earlier. Okay, there we don't use this kinds of constant equation. We have used just our prediction, our intuition. But when the system will be more complicated, our intuition or our prediction will not work very well. Okay, so in that case we have to use the constant equation. Suppose if there is another pulley, okay, so the system will be more complicated. If there is another pulley, suppose, and there are also two masses, m2, m3, m4. Okay, then you cannot predict the acceleration between these three masses. If this mass is downward direction, this will be in upward direction, this will be upward direction, this will be in downward direction. So various kinds of acceleration there. Okay, sometimes the system will be more complex, 3, 4, 5 pulleys are involved. The questions are asked in JEE advanced exam like this. Okay, so in that case you cannot find the relation between the acceleration, and in that case you have to use this method. I will do more complicated problem in the next class. This is just this class is dedicated to concept or clear. Okay, just to concept or clear. So with the very basic problems we want to do the concepts, clear your concepts. Okay, you have to very clear about your concepts such that you can apply your concepts in more complicated problems. So the very basic things is what I am saying till now, that the first thing is that what is actually mean by constraint. Constraint means restriction, and the restriction is due to the nature of the system. It may be any types. It may be sometimes in the form of normal reaction, it may be sometimes in the form of tensional force, okay, or many other cases there will be different cases. But we have to understand the actual restriction in terms of equation like this. and then from there what we will get, basically we will get the relation between the acceleration. So there we will get there a more extra equation. Okay, there is the relation between a1 and a2, and this is very needful actually. You cannot solve the problems only by using the Newton's law. If you don't know the constraint, you cannot solve the problems only by using Newton's law. But when we are asked very simple problems, then we can assume something, okay, and that will work, sometimes work. But when the system will be more complicated, the prediction will not occur and not work, and we have to use this constant equation. Let me understand what is the need of this constant equation in very simple way. For this example, we can understand in a very simple way, okay, that what is the need of this constant equation. Why I am saying that the Newton's laws are not sufficient to solve some problems, some complicated problems. We need to know another extra concept or extra equation. We have to know about another equation, that is Constraint Equation, that will provide something that you need and which cannot provide only by using the Newton's law. Okay, so let me understand this thing again by using this example. Why this relation is very needful to us for solving problems, more complicated problems. Okay, so let me understand this thing again. So if you think very carefully about this mass pull system, if you don't want to use our prediction, if we want to solve the problems totally mathematically, if you want to solve the problems mathematically, then you will face problems. Okay, but we actually use our prediction, but we can't understand. Okay, sometimes we can't understand, but we will use our prediction. For this problem, this is very interesting and this is very nice concept. Okay, you can understand. This is a very simple thing. I like to give you a very simple example so that you can understand all the things. So I have told recently that let me suppose that the acceleration of this object is a1 and the acceleration of this object is a2, because you don't know. We don't know. Here also this is also the prediction that I have taken a1 in this direction, a2 in this direction. This is also prediction. So even if you want to know about mathematically, then we also here we don't know the magnitude of the acceleration as well as the direction of the acceleration. But in the previous problem, what we have done? We have done the acceleration in this direction, the acceleration of m1 in this direction. When I have solved earlier in the previous class some mass pulley system, 4 types of problems I have solved, but they use only one pulley problem. And there what we are used that the acceleration of this is a and the acceleration of this is a along this direction. So two things we assumed here. First, the acceleration of m1 and m2 are same, and second, they are opposite in direction. We have used this prediction again and again. But if you don't want to use this prediction, what you will do? You will just put the acceleration in any direction. So let me put the acceleration a1 is along in this direction along with vector sign, and along in this direction with vector sign. Okay, now how you can understand what is the relation between this acceleration? I have told you earlier recently, but my question is different here. If you ask to solve these problems, that two questions may be asked here, that find the number one question is find the tensional force, find the tension in the string. That should be the first question. Find the tension in the string. And the second question may be find the acceleration of both the objects, both the blocks. So the second question should be find the acceleration of both the blocks. Okay, so do you know what are the number of variables? Here the number of variables is 3. One is tensional force and 2 others is the acceleration. So 3 variables are unknown here. We need to find out 3 unknown variables. One is tensional force, another is a1, and another is A2. But we have only two equations according to Newton's law. We can use summation F is equal to ma for this mass and summation F is equal to ma for this mass. So we have only two equations, but we need to solve three variables. So we can't solve by using only Newton's law. So what we have to do? We have to know about the relation between this acceleration also. And from where we can get the relation between these accelerations? Only from the constant equation. Maybe you can write it in the form of constant equation, maybe you use your prediction. That's the different case. You can jump your step by assuming something in your mind. That's not actually the counting thing. We can't count this thing. It is not sure that you can everywhere you can predict like this. I have given you example recently that you cannot assume these things that acceleration A is in this direction and acceleration A is in this direction in downward direction. You cannot predict this. You can derive this thing by using the constant equation. As I have said earlier, that you should take x1 plus x2 is equal to constant, then you should make derivative, and you will reach to this equation that a1 is equal to minus a2. And this will suggest you that if the acceleration of this mass is in this direction, then the acceleration of mass m2 will be in this direction. So this is the beautiful thing about the constant equation and the concept of constraint. And there is a huge application of this thing in Lagrangian and Hamiltonian mechanics, in classical mechanics, advanced classical mechanics. But we are not in that domain. So what we will do, we will just use the concept of constraint to solve some particular problems like this. Similarly, I can give you another example that you can understand that sometimes what the things that we have assumed in our simple problems where you can involve the constant equation, but we have not involved because we have used our prediction. Just we have used our prediction. Okay, that you can say over here that this is a mass capital M, okay, and a mass small m is attached here, and a force F is acting along this direction. So if the acceleration of the system is A, then you can say that the acceleration of this mass is A and the acceleration of this mass is also A, because these two masses have to go together. So the acceleration of these two bodies must be same. So what is the constant here? Here the constant is also that this mass m have to move with this mass capital M. This is the constraint of motion of this mass small m and capital M. They have to move together. This is the constraint. And we use our prediction here also that the acceleration of these two mass is same, and we use the Newton's law and we will get the answer. Okay, so but this is not actually the work of only Newton's law. There is something hidden, and that is constant equation. And for more complicated problem, we have to use this. Like again, I can give you an example like this. This is a wedge, you can say, and it can move freely. It can move freely with a smooth surface. And if a mass m is moving in this direction, then what will happen? This object will move in this direction. So can you relate the acceleration of this and this object? Can you relate? Here the acceleration of this object is along this direction, and the acceleration of this object is in this direction. Can you relate mathematically what is the relation between A1 and A2? You can't, because this is a more complicated case and our prediction will not occur. So we have to use the constant equation, and we will use these kinds of things, and this is called wedge constraint. This is actually called wedge constraints. And in the previous example that I have given earlier, that is pulley constraints. Okay, mainly we will use or we will solve the example based on these two types of constraint. One is pulley constraint and another is a wedge constraint, and sometimes we will combine these two. Okay, so the problems are coming. The problems that are coming will be more complicated. Okay, when these two kinds of things will work together, that pulley constraint as well as wedge constraints. So we will discuss from the next class. First we will discuss about pulley constraints, then we will discuss about wedge constraints, then we will discuss about the combination of these two. Okay, and before solving more problems, I try to make your concept more clear. Once your concept is clear, then you can apply the concepts in problems very easily. How much complicated the problems may be, but you have to solve, and you can do if you have conceptually very clear. Okay, so in the next class I will discuss that thing. Okay, for today, thank you.